Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. In our last video we looked at multiplexers. In this video I want to simulate some of the multiplexer circuit schematics that we developed to talk about the 2-to-1 and the 4-to-1 multiplexer. I'm using Multisim Live to do the simulation, so if you are a part of PLTW, you probably have access to Multisim as a installed software on your Windows PCs, or you have Multisim Live. And so I have a Mac, so I don't have a Windows PC, so I am using the live version. Please follow along. Let's get started. So I'm going to start with a 2-to-1 multiplexer, and let's go ahead and start building it by putting our AND gates. And we had 2-to-1 AND gates. To make this happen, go ahead and duplicate that. And then I want an OR gate. Oops, a little bit of lag here. And we want a 2-to-1 OR. And we'll go ahead and connect these together. Fantastic. And we also need some inputs. So I'm going to create my selector input using one of these digital inputs. Okay, and then we need an inverter. Okay. We'll connect these together. And so if remember, if it comes in as a 0, we want to activate our top AND gate that's associated with the input 0. And if it comes in as a 1, I want to activate the bottom one. And so that is the configuration to activate the appropriate input. We also want some visual output, so I'm actually going to choose an indicator of an LED. And we'll put an LED there, and we'll put a current limiting resistor in, and we'll rotate that, place it right there, perfect. And let's change its value to 220, perfect. We need a ground, and go ahead and connect these together. So now we have an output. I do want to change this from red to white. I think it gives us a better look at the output. Now for us to know that we're looking at either input 1 or input 0 or input 1, I'm going to attach a digital clock. And so this is going to cycle the output on and off. And I'm going to choose 2 different rates for which this will occur, and then we'll see that we are selecting the right channel and that it's actually performing what we expect it to be doing. So I'm going to choose a digital clock, and I'm going to choose that for I0, and I'm going to choose that digital clock for I1, just like so. Okay, and I'm going to change the frequency here. I don't want it in terms of kilohertz, I want it in terms of hertz. And so we're going to go 4 hertz for channel 1 and or for channel 0, and 1 hertz for channel 1. And let's go ahead, and right now I have selected 1, so that's going to be channel 1. And so let's go ahead and take a look. And so this is cycling 1 time per second. And so that's what you see it turning on and off 1 time per second, because we are feeding channel 1. We're activating the AND gate. You can see that the other output from the top AND gate is staying at 0. This one is alternating with the same frequency as the digital clock. And so we can see that happening right there, and it's turning on and off. So we're passing through that, that input I1 directly into the output. Now if I flip this selector to 0, now we're selecting the top pathway up here, and so because of that you can see that the rate at which the output is cycling is a lot higher, and so we have that set at 4 hertz. Okay, awesome. That looks pretty cool. So some fun simulation here as we can see the functionality of a 2-to-1 multiplexer. Dare I build a 4-to-1? Well, there's not a whole lot that's different for a 4-to-1, but let's go ahead and give that a go. So if you are not interested, feel free to leave at this point. Okay, so we're going to need 2 selectors. So I'm going to go ahead and select or make some duplicates here. Oops, not what I wanted there. Okay, perfect. Okay, let's do it like this. And now I need 4 AND gates, and they need to be 3 input AND gates. Let's put them up here. Let's see, right about here. Duplicate. Duplicates. Duplicates. Probably spread those out a little more, huh? Maybe right there. There. Okay, good enough. And now I need a 4 input OR gate. We'll connect that to the output. So not that I'm sponsored by Multisim, because I'm not, but you can see that it's such a great tool, and how quickly we can build this up is really fun. All right, so I'm going to move this one up. We're going to do the same thing with the inputs. Let me duplicate this, and that one's here, and I'm going to duplicate, and then that one is, well, I'll just put it down here, and then we'll move this guy up to here. Okay, so let's go 4 hertz. We'll go 3 hertz. Actually, let's do 2 hertz, 1 hertz, and half hertz. Awesome. Okay, so we'll connect these now straight across to, oops, there we go, to their inputs. Okay, so we're going to have selector 1 on the left and selector 0 on the right. And so remember that this is I0 at the top, then I1, I2, and I3. So I want I0 when both inputs come in as zeros. And so that means that I want them to be inverted to make them 1s. And so no, I don't want it like that. I want it like this. So I want that inverted version. And I wanted this inverted version right there. Okay, so that will give me 2 zeros coming in. We'll turn them into 1s, activating this AND gate. So for the input number 1, I want 0, 1 to do the same thing. So we're still gonna invert S1, but this time I want to use the S0 not inverted. And then for 1, 0, it's the opposite. So for S1, I want it to be not inverted. Oops. Let's see why it didn't let me. Well, it didn't want me to connect right there. I don't like it. Okay, we're going to do something here. Let's see if we can move each of these guys back a few. This should do what I want. Okay. So yeah, so sorry, lost my place there for a second. So for 1, 0, we want not inverted, and then inverted for S0. So right like that. And then for 1, 1, we don't want either of them inverted. So I can go to these non-inverted lines, just like that. All right. That looks awesome. Super exciting. Okay, let's see if it'll work for us now. So right now it's selecting 0, 0, so it should be the top one. So we should have a rate of about 4 hertz. Oh, and there it goes. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So it looks pretty good. And we can see that the bottom 3 paths coming out of the AND gates are doing nothing, but the top one is passing through the input, which is what we want. So now if I choose 0, 1, we choose the 1 input, and there it is. Now it's at 2 hertz. 1, 2, 1, 2, 1, 2, right? So it's at 2 hertz instead of 4 hertz. And again, we can see by what's lighting up that we are indeed selecting that path. And now we're selecting 1, 0, which is the 3rd input. And you can see that one's lighting up, and this is 1 hertz. So we got 1, 2, 3, 4, and the rate has decreased again. And finally, at 1, 1, we select input 4, pass that through. 1, 2, 3, 4. You see it's much slower. So there we have it. So these are the implementations of the 2 to 1 and 4 to 1 multiplexer using AND, OR, and inverter gates, the AOI implementation. So you can see how it's working and why it works. Hopefully that gives you a better understanding of the last introduction when we looked at the theory behind that. I hope you enjoyed it. I hope you found it to have value. I'm Mike Stanzik. This is Digital Electronics Classroom. Please be sure to subscribe, and we'll see you on the next video. Have a great day.